Hello, here we go. We are going to make it through some problems that will help you to prepare and kind of have an overview of the work that we've done in this unit, covering trigonometry, unit circle, graphs of sine and cosine, sine, cosine, tangent, their reciprocal functions, graphing some of those, and also applications of sinusoidal functions. So that's sort of the overview. I'm going to break this into a couple of different parts. So this particular video is going to be sort of the basics, some converting, some working with Pythagorean theorem, and some writing equations from graphs and graphing from an equation for sine and cosine. So that's what's going to be covered in this video, and then we'll kind of roll it into a different video for things like reciprocal functions and applications. Okay, so the first thing that you need to be able to do is just convert from radians to degrees and degrees to radians, and sometimes we'll have nice, clean information that are degrees or radians from our unit circle, like pi over 3 is 60 degrees, and 315, where is that? Right, so a lot of times when we're working with the unit circle, it's helpful to be able to just kind of think about it and visualize it and kind of know where 315 degrees is, so you can get that equivalent radian value. You could express it as negative pi over 4. That would work, or 7 pi over 4 if you needed to describe it as a positive radian value. And if we don't have nice stuff on the unit circle, you can also take something like pi over 7 and convert it, remember, by multiplying it by 180 over pi. Okay, so pi values would cancel, and in this case, let me get my calculator out and going. So we're ready to go. 180 divided by 7. So that would end up being about 25.7 degrees. And in the same kind of fashion, if you had some degree measure like, I don't know, 111 degrees. Okay, we know that's not on the unit circle, so instead you're going to have to multiply pi by pi over 180. You'd try and do your best to reduce that if you could. Maybe we should make it 110 degrees, just so it's easy to reduce a little bit here, right? That's going to be 11 pi over 18, and that will not reduce any farther. Okay. So let's go ahead, and now that we've kind of covered those, I think that's pretty straightforward. And again, with any time that you want to stop the video and work through a problem first on your own, I would strongly encourage you to do that, because that's a great way to study, is to take a video where you know the answer is going to be given, and to stop the video before the answer is given and try it yourself. Okay, so like right now, there are two problems here. I would encourage you to stop the video and then turn it back on to find out if you got the answers correct, because that's a really great way to study. But I'm just going to keep going, all right? So I've given you lots of time to pause if you chose to do that. Okay, so the point -8, -2 is on the terminal side. That means the ending side of an angle in standard position. So I'm going to find -8, -2. 1, 2, 3, 4, 5, 6, 7, 8. -8, -2. And so I know this is going to be -2. This is going to be -8. And I'm going to use the Pythagorean theorem to find this hypotenuse. Okay. So it's kind of this angle that we're talking about, but remember this angle that is with the x-axis right there, that's going to be our reference angle. And then there are 6 trig functions we're going to find the values for, and we also want to rationalize denominators, so we are going to end up with the sine of theta and cosine, also tangent, cosecant, let's see, secant and cotangent. All right. So I'll probably pause when we're kind of going through this, just so you don't have to watch me write for so long. But remember, on a problem like this, how we're going to get started is we are going to find this hypotenuse, okay? -8, -2 is going to be in the third quadrant, so the tangent is going to be positive, but your sine and your cosine functions are both going to be negative, all right? So essentially what we're doing is we're going to square our -8, square our -2, try and find, we'll just call it c squared for the hypotenuse. So 64 plus 4 is going to be 68 is equal to c squared. If you can reduce or simplify your square root, I'm going to want you to do that. So we might be able to with 68, right? So 68 is the same as 17 times 4. So another way to write our value for c is going to be 2 root 17. Okay, so that's going to be a nice little value for us to work with and to reduce fractions here and there, and also perhaps rationalize our denominator. So now that you know that this hypotenuse is actually 2 root 17, see if you can take a minute to write all of your trig functions. So remember, for sine, opposite over hypotenuse, you're going to have -2 over 2 root 17. There's going to be some nice simplifying that's going to go on there. Its reciprocal is going to be a -2 over root 17 divided by 2, which is just going to be a negative root 17. So that one's an easy one to simplify, right? And so this one probably is going to just end up being negative. Probably got root 17 over 17 because the 2's are going to cancel. So go ahead and try and write these other values just like that, and I'll check back in with you in 2 shakes. They'll appear. All right, so take a look and see how you did on these. I went ahead and kind of did some work on simplifying right through here. I get this for the cosine of theta, but then I went ahead and rationalized the denominator to get this value for a final answer. And then, of course, taking the reciprocal, just working towards something like that. And 1/4 and 4 over 1 for cotangent. Things are simplifying nicely. And then these are the last 2 answers I got for sine and cosecant. Okay, so hopefully those worked out and you guys got something similar. And yeah, let me know if you didn't. All right, we can talk about it. All right, moving on to the next one. Again, great time to pause if you haven't already tried this one. Here we go. We are going to try and find the 5 for my friend Colin. I put that in just for you. I don't know if you'll be watching, but there you go. The 5 trig functions that are remaining after we already know that the secant of x is equal to -5 over 2. So if we're going to go through this and we're going to try and find the sine, right, and the cosecant, again, it's finding all of the values of our trig functions given a location of our angle. Cosine, right, and secant, that's the one we know already, is -5/2, which is nice because that helps us to know the cosine is -2 over 5. We'll use that. I like to kind of think about it in terms of cosine. Kind of helps me. It might help you as well. And then we know the tangent is going to be positive. Oh, no, look. Tangent of x is less than. So in this problem, it's less than 0. So our tangent is going to be negative, which means our cotangent is also going to be negative, right? And what that helps us with is it helps us to draw our picture, right? So if we know tangent of x is less than 0, then we must be either in the second quadrant or the fourth quadrant. And because cosine and secant are negative in the second and third quadrants, this is where we have the overlap of that paired information that helps us out. So I'm going to use this cosine of negative 2 over 5, right, adjacent over hypotenuse, and I'm going to go over negative 2. I'm going to draw my little angle here. Maybe I want to draw it a little steeper just so I can make it a little more to match. There's my 5. There's my right triangle. My reference angle is always coming back to my x-axis, right? And so once again, you're going to have to use Pythagorean theorem to find out your missing side here. So let's do that just real quick. So what's that going to be? B squared, we're just going to do some fast math here. 21, so b is equal to the square root of 21. That cannot be simplified. This is going to be a positive value, right? Help sign be positive. So again, you can stop. If you haven't stopped already, maybe stop and see if you can do the whole rationalizing the denominator piece. But here we go. All right. Sine should be root 21 over 5, which makes the cosecant 5 root 21 over 21 when you rationalize the denominator. Tangent should be negative. It looks like it's going to be, what, root 21 over negative 2, opposite over adjacent. So root 21 over 2, that's going to be negative, which makes our cotangent, I'm going to write it right down here, negative 2 root 21 all over 21. That does not simplify. And there are all of your trig functions. Okay. The next piece is going to be a little graphing, writing equations from graphs. And depending on if you were a snow day person or not, if you were a snow day person, you might want to try writing equations for both of these, okay, as we move forward. If you were not, if you were in my LZ cohort gang, you've already done this, this first question, but I threw in a second question just for you to try. And why don't we try to write these in terms of sine and cosine? So first write this equation in terms of sine and cosine, and then come down here and write this equation in terms of sine and cosine, and just do your best. And remember, a great way to start each time is to identify what your vertical shift is, what your amplitude is going to be, what your phase shift would have to be for sine or cosine, what the period of the function is. You can kind of determine that from going like top to top for a cycle, and then using that period to calculate your b value. Okay? So I'm going to give you guys a minute to do that, and then I'm going to come back and we're going to see if we can't talk our way a little more through the second one. You can double check your answers on the first one as well. Again, a lot of different kinds of ways we can write the equation for this based on how we utilize our phase shift. Okay? So you may come up with an answer that I haven't come up with, and that's totally okay. All right, give it a try. Okay, so I wanted to get back to you on these. Of course, the answers for the top one are already done, so you can pause and check those out at your leisure, but I wanted to kind of come back to you in time to talk to you a little bit about the phase shift and the b value for writing your equation. So we have a vertical shift of 1, an amplitude of 1. If we write this graph, don't forget your cosine is going to be kind of this shape, and then if we do a negative cosine, it starts from the bottom and then comes back down. That would be if you want to write your graph in terms of a negative cosine. Your sine function is going to start from your sinusoidal axis and move up first, then down below it. If you do a negative sine, write in terms of negative sine, you're going to drop first from your sinusoidal axis and come up. So you have some choices to make about where you want your phase shift to be. I'm going to go ahead and put my phase shift back negative pi units, so pi units to the left for my sine function. So I'm just going to say sine function is going to be left pi units, so I can write my equation. Okay. And then for my cosine function, you can see that it's starting right at the top, right over here, at 0. So my cosine function, I'm good to go. I do not need to use a phase shift for that. My b value, I noticed that my period, one cycle of the function, happens from top to top, is 4 pi units long. So once you know your period, don't forget your b value is going to be 2 pi divided by that period. So in this case, that reduces to 1/2. So we can go ahead and use this information now to write our equation. So let's write the cosine one first. So y is equal to 1 plus our amplitude of 1. We can either write it or we don't need to write it. Cosine of 1/2 times x plus, oh, did we have a phase shift? I don't think we did, right? That is going to be for sine. So we just are going to write x. Have you guys here in class to catch me on those. And then, of course, the sine function, everything is similar. We're going to go ahead and write it in terms of our shift to the left. So because we're doing a shift to left, it's going to be x minus pi. Plus pi. Sorry about that. There, that looks pretty good. Now we could write it in terms of 1 plus sine of 1/2 and do x minus, but if we were going to shift to the right and use a positive sign, we'd have to shift all the way to here and say minus 3 pi. Okay, so again, a lot of different ways to write our equation. All right, guys, let's move it on. Kind of last little chunk for this video. It's kind of a long video, but it is kind of the majority of what you need to know, I think. Moving forward, the next two may not quite be quite as long. So go ahead and try to graph this particular function. Okay. Again, I think it is a really good idea to identify from your information the vertical shift amplitude, again, what your phase shift will be, and then what the period of the function is. And it's important to look at these two pieces and, of course, you know, all this information that you're going to have to put into your graph prior to graphing and setting up your XY axis. It'll just help you with numbering things. You might notice here that because your phase shift is in terms of radians, see how your phase shift is going to be in terms of radians right here? That means that you probably, when you set up your x-axis, you probably should set up your x-axis in terms of radians, right? So you can do a phase shift that's nice there. All right, so I'll give you a minute and then I'll come back. All right, so here's some information that we gathered from our equation. And probably the biggest thing to note is that in creating your x-axis, once I found out that the period was 5 pi units long and that I was going to shift my graph pi units, I just made my x-axis in terms of 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. All right? One of the things we've talked about in class is actually graphing this prior to making your phase shift. You can certainly do that and then do your phase shift at the end. We see that our vertical shift is 5. One thing to note is this negative sign right here with the 3 is going to mean that our sine picture is going to drop down first and then come up for my sinusoidal axis. So this is going to be the picture that I need to kind of get onto my graph. I see my amplitude is 3, which means I'm going to go up 3 and down 3, right, from that sinusoidal axis that I know is at 5 now. And I know I'm going to shift over pi units and that there's a total of 5 pi units in the period of my function. So what I know is that I'm going to be finishing here. I'm going to be starting here at pi. And then 5 pi units, so 2.5. So at about 3.5 pi, that's going to be a center point, right? We have all this symmetry. And since we have half there, it's probably going to be down to 2, somewhere in here, and over to 4 point something pi, and all the way up to 8. So these numbers are going to be important to show when you develop your graph, because they let me know that you know what the sinusoidal axis is, what the amplitude is, and then your picture should look something like that. Da-da-da-da. And you just have to do 1 cycle. All right. Nice work today, guys. That was a 20-minute video. Woohoo! All right, 20 minutes of good practice to get ready for your exam. And there are a couple more coming at you, but again, you can do all or part of these, fast forward them, whatever works for you. All right, good luck.